In today's session, we're going to look at protocols in a bit more depth, hopefully to show a deeper understanding of common protocols like HTTP, FTP, POP3, IMAP, SMTP, and a deeper dive into the BitTorrent protocol. You need to be able to understand what the purposes of these protocols are and how they operate. Now, before we begin looking into this, I want you to start thinking about what we covered in the previous lesson, where we looked at TCP/IP suite of protocols and how there was that physical layer where you had to then transmit data over. So you went through application, transport, internet, data link layer, and then the data packets or the frame that was assembled in the last layer is transmitted over a physical connection, a wire, possibly an Ethernet cable for local area network transportation. And remember, we don't just send things from your device to a web server halfway across the world. Everything happens in local area network chunks. So your device will just know the router that you have, and the router will probably know the main server or the exit point, and that exit point will know the ISP. So everything is a connection of local area networks. So that physical connection is hardwired, it is absolute, it exists in the real world, whereas the software in other form is more abstract, is coded, it lives on the computer. And then obviously once it gets to the other computer, it goes through the stack, so you disassemble it using each of those layers until you get the data packet back. However, physical is not the only way for you to communicate. But nowadays, we've moved beyond physical. We've got access to protocols which are Wi-Fi based, Bluetooth is there, WiMAX is there, and of course, there are other ways of connecting devices instead of a client-server type network topology, and that's peer-to-peer. So as usual, let's start with a prior knowledge check. Make sure you know how the TCP/IP protocol can be viewed as a stack, why protocols are actually needed. You should be able to name 4 common protocols, and what happens in the internet layer of the TCP/IP protocol. So do pause the video and think about these questions, then continue when ready. Okay, hopefully you thought about the use of layers and how each layer passes packets or data to the next layer. It all acts as a stack. So if you think about it, application sends the packets to the next layer, which is the transport layer. The transport passes on to the next layer, which passes on to the following one. So you got packets turning into segments, into datagrams, into frames. They go over the physical cable, and then when they come back out, they're output as the last one in, but the first one out. So the last one in obviously is the data link layer. That tends to be the first one out, just like a stack. So why are protocols needed? Well, without those protocols, there would be no standardization, no communication that might occur between a sender and receiver. So something along the lines of that. Name 4 common protocols. Hopefully you got HTTP, SMTP, IMAP, DNS, you name it. Lots of others. What happens in the internet layer of the TCP/IP protocol? You should be able to explain that identifies the intended network and host. The IP addresses are added to the segment that comes from the transport layer, and then it's turned into a datagram. The IP layer ensures correct routing of packets, is responsible for the relevant protocols, and it takes that segment from the transport layer and adds its own header, which will include the IP addresses of both sender and recipient. And then it passes that datagram to the data link layer, where it will be assembled into frames. Okay, let's start by looking at some common protocols. And the first one we're going to look through is the file transfer protocol, FTP, which is a standard network protocol used to copy a file from one host to another over a TCP/IP based network such as the internet. By copying from one host to another, you could say, for example, upload a website with pictures from your computer, or perhaps you can use OneDrive or Google Drive, any software that requires file uploading. FTP normally works on port 21, and there are many well-known port numbers. Some of those are on screen towards the top right. 21 is used for FTP, 25 for SMTP for email, sending of email. 80 and 8080 are used for HTTP, so commonly web browsers will be probably using this protocol, and then 110 for Post Office Protocol, or POP3 for receiving emails. And of course, there is the most common one, HTTP, which stands for Hypertext Transfer Protocol, a networking protocol behind the World Wide Web, and it allows users on the web to exchange information found on web pages. It normally works on ports 80 and 8080. This makes use of hyperlinks, which are basically rules for transferring of data over the internet. And it's a client-server protocol which requests messages and are sent out to web servers, which then respond to these messages by sending back HTML data. You also need to know the summary of what happens when a user requests a web page from a website. Normally, step one is the user keys the URL into the browser. The HTTP part transmits the request from the application layer to the transport layer. The TCP creates the data packets and sends them via port 80 to the destination port. The DNS server stores a database of URLs and matching IP addresses. The DNS server uses the domain name that's been typed into the browser to look up the IP address of the appropriate website. The server, TCP, sends back an acknowledgement. Once communication has been established, the web server then sends the web page back in HTML format to the browser. The browser finally translates the page and displays it, or sends the data in the correct format to a media player, so video and audio could be played. That's basically the process of how HTTP works, and you could also use the same process with HTTPS, which is the secure version of HTTP. Now, the next protocol we're going to be looking at are actually a group of protocols to do with email, so SMTP, POP3, IMAP. The simple mail transfer protocol is a text-based protocol, which is sometimes referred to as a push protocol. In other words, a client opens a connection to a server and keeps the connection active all the time. The client then uploads a new mail to that particular server. Now, since SMTP is text-based, it doesn't handle binary files. If an email contains attachments, it's necessary to use a MIME, or multi-purpose internet mail extension protocol, instead. A MIME header is used at the beginning of the transmissions, so the email clients can select the right software to open any kind of attachment. Now, POP3 and IMAP are protocols used when receiving emails from an email server. These are known as pull protocols. The email client periodically connects to a server, checks for and downloads new emails from the server, so it's pulling those emails. IMAP is more recent than POP3, but both have been actually superseded by the increasing use of HTTP protocols. SMTP is still used when transferring emails between email servers. However, you might encounter that both IMAP and POP3 aren't as relevant anymore, but for the purposes of exams, you still need to talk about them. The main differences between POP3 and IMAP are to do with synchronization. POP3 does not keep the server and client in sync. When emails are downloaded by the client, they are then deleted from the server. IMAP keeps the server and client in sync, so that means only a copy of the email is downloaded, with the original remaining on the server until the client manually deletes it. Now, at this particular point in time, it's also useful to visit the CSMA CD protocol, and this is a bit of a recap from AS level. So a data frame sent changes the voltage on a cable. When a collision is detected, a node stops transmitting and sends a jam signal, waits for a random amount of time, and then starts retransmitting. It'll keep transmitting, and it'll keep updating the transmission counter for every time it attempts transmission until it reaches max. So when the max transmission counter is reached, at that point in time, it stops transmitting because the line is too busy. Since we just talked about CSMA CD protocol, it's useful to know about another protocol which has a similar sounding name, and this protocol is related to the Wi-Fi protocol that we use every day. The protocol is called Carrier Sense Multiple Access, CSMA, with collision avoidance. So instead of collision detection, it's collision avoidance, CSMA, CA. And this one is utilized for wireless LANs, which normally use a MAC-based protocol, which is media access control. And it uses a distributed control function, or DCF, to ensure that a wireless device can only transmit when a free channel is available. Since all transmissions are acknowledged when using DCF, if a device does not receive an acknowledgement, it will assume a collision will occur and it waits for a random time interval before trying again. Now this is quite different from collision detection, where you transmit and then you detect. Here you will not even transmit until you get an acknowledgement from a router or another device that it's okay to proceed. And this is an important protocol which ensures the security and integrity of data being sent over a wireless network such as a WLAN. Normally it's known in the wild as IEEE 802.11 protocol, and if you just look at your Wi-Fi settings, chances are you'll probably see this referred to as 802.11 protocol or something similar to that. The other protocols you need to be aware of are Bluetooth and the WiMAX protocol. And Bluetooth we covered in a lot of depth at AS level, and it might be useful for you to revisit. It's used for short-range data transmission. And WiMAX, which stands for Worldwide Interoperability for Microwave Access, runs under IEEE 802.16 protocol. And this connectivity was designed originally for wireless MANs or metropolitan area networks. However, you can get fixed WiMAX networks, which are based on the IEEE 802.16 2004 version of the protocol. And mobile WiMAX is based on IEEE 802.16 2005 protocol. So there are different variants for this protocol available for fixed and wireless. And if you're interested in knowing what the IEEE version for Bluetooth is, it's 802.15. So 802.16 is WiMAX, 802.15 is Bluetooth, and 802.11 is the wireless protocol. Okay, enough about protocols. Let's move on to peer-to-peer network. Now, if you remember from AS level, a peer-to-peer network or P2P network is created when two or more PCs or devices are connected and they share resources without going through a separate server computer. Now, a P2P network can be an ad hoc connection, which means it can be assembled between just two devices, or it can be a network on a much greater scale, which is organized in advance, in which applications set up direct relationships amongst users over the internet. And most P2P programs are focused on media sharing, and hence they're associated with software privacy issues and copyright violation, piracy, all of those kind of things. And a famous example of a P2P application shares the name with the most common protocol. It's called BitTorrent. Now remember, there are two things. There's the BitTorrent application, and then there is the BitTorrent protocol. We're interested in the protocol. Now, why BitTorrent? What's the point? Why not a server-based application or protocol? Well, the benefit of BitTorrent is that it allows for very fast sharing of files between computers. And these computers are often known as peers, and we'll get into all of that in a moment. While peer-to-peer networks only work well with a very small number of computers, the concept of sharing files using BitTorrent can be used by thousands of users who connect together over the internet. So instead of sharing everything network related, which obviously can cause a lot of issues with bandwidth and collisions, we only share files. And this allows multiple peers or multiple computers to act as web servers. So instead of getting your data from one web server, suddenly you're getting it from 1,000 web servers, and that speeds things up. So the BitTorrent application acts similar to a web browser. And just as a web browser needs websites to be useful, the BitTorrent needs special files called torrent file. And these torrents contain metadata about the file about to be shared. The actual file is broken up into equal segments known as pieces, so think about those as packets. Other peers who wish to download this file must first obtain the torrent and then connect to the appropriate tracker. A tracker is a central server that contains data about all of the computers that are connected to it, so the entire swarm that's related to that particular file. As each peer receives a piece of the file, they then become a source for that piece of file, and then other peers connected to the tracker will therefore know where to find that piece of the file they need. Once a peer has downloaded the file completely, they make the file available to other peers in the swarm, and the swarm is a group of peers connected together basically. They also become a seed. The more seeds are there in the swarm, the faster the file downloading process between peers. Now what happens is that sometimes there will be people that will download a file and then log off. And this is not really acceptable. So these type of peers are termed as leeches. Now usually once a file is fully downloaded, a peer is also requested to remain online so other people can be part of the seeding process. And that's how the speed of the network is maintained. Otherwise, imagine you download the file and then you just log off, and then the remaining people might just end up on 90% of the file and they never have the complete file. So that goes against the grain of the BitTorrent protocol. Remember the goal of the BitTorrent protocol is to ensure that all the file pieces are available and rearranged in the correct order. So you end up producing the final file. And anything that stops that from happening is generally frowned upon. So make sure you know the key terms: swarm, a group of peers connected together; seed, a peer that's downloaded the file and has then made it available to other peers in the swarm; tracker, a central server that stores details about other computers that make up the swarm; leech, a peer that has a negative impact on the swarm by having a poor share ratio. And what's the share ratio? That's basically the amount of data the peer has uploaded or made available for other people versus the amount of data that the peer has downloaded for their own use. Generally, the ratio has to be 1 or greater than 1 for a positive impact and less than 1 for a negative impact. One more term I'd probably introduce here is a lurker, which is a peer that downloads many files but does not make available any new content for the community as a whole. Because imagine if everybody was a lurker, there would be no new files shared ever on the torrent network. And that's probably one of the main reasons why BitTorrent is declining in popularity. I think at peak it was 35% of video and audio traffic on the internet, and now it's 3% or less than 3% in 2022. So it's declining. Though also do remember that the ratio of people using the internet to stream audio and video has increased as well. So take that figure with a grain of salt. It's still very popular, but not as popular as it was at its peak. Okay, that's the end of this particular lesson. Hopefully you've understood how the BitTorrent protocol actually works. You've got a bit of an understanding of other common protocols like HTTP, FTP, SMTP, POP3 IMAP, also the WiFi protocol, WiMAX, Bluetooth, you already should know from AS level, and the BitTorrent protocol. You should be able to answer questions such as what is a torrent, a file that contains metadata about all the different pieces of a file that somebody wants to download, what is a tracker, a central server that has the details of all the swarm, the seeders, the peers, all of them together. If you do have any questions about this, please feel free to get back to me. Otherwise, that's it for this particular lesson, and I will see you in the next one.